we really appreciate the work that the Passive House Accelerator has been doing, helping to spread the word of how these principles can really make a big difference to our climate goals in the state. And what I'd like to do, if Laura, you could put up the first slide, I'd like to give you just a very quick whirlwind tour of the policy context in New York for anybody who's not aware of that. I'll try to keep this to 5 minutes. So we do think we have the most comprehensive climate legislation in the country. People from California may try to arm wrestle with us over that, but I do think that with the continuity of our act and our project, we're at least right up there with California, if not a little bit more comprehensive. So what are we looking at? We're looking at the Climate Leadership Community Protection Act. I'll just call it the Climate Act, which requires that we get on a statewide economy basis to carbon neutrality by 2050. And that's through at least an 85% direct reduction in greenhouse gases, and anything we don't get there on the direct reduction would have to be through offsets or sequestration, with a 40% reduction by 2030 milestone. And importantly, it integrates some other elements, including our clean energy standard, which requires that all electricity generation come from renewable energy by 2030. And by 2040, our electricity grid needs to be 100% emission free. And that, of course, is really critical because it means electrification becomes an extremely powerful decarbonization tool. Next, Laura. So why do we focus on buildings? Probably don't have to jump up and down on this for this audience, but a third of our emissions economy-wide in New York State come from direct emissions from buildings through on-site fuel combustion and the release of HFCs from refrigerants. If you add in the electricity use in buildings, that number goes up to about 45%. Eventually that will shrink to zero once we get to the zero carbon grid, but we're still left with a third that we need to get at of emissions from buildings. And if you see on the right, it's largely from space heating. About 2/3 of it is from space heating, big chunks from single family and multifamily, and then water heating and cooking. Next slide. So the Climate Act set up something called the Climate Action Council, which is a body that was supported by a number of different working groups, including one on buildings and efficiency, that has come up with what's called the scoping plan, which is all of the strategies that are being recommended or would be required to reach carbon neutrality by mid-century. One of the chapters is about buildings. That's where I will focus now. We're currently in a process, a public comment process. If anybody's interested, please submit comments on this. There is staunch opposition from the likely suspects, fossil fuel industry, et cetera. So positive comments are really important, and there are 6 different sessions coming up to make public comments. You can just send written comments in as well. But some of the really important strategies here are about regulation. We want to do everything we can about market development, reducing the cost of these projects, supporting innovation, et cetera. But in the end, to get to these goals by 2050, we need regulation. One of those is about new construction. We have a proposal on the table right now for an all-electric new construction code requiring all-electric, no fuel, fossil fuel or oil hookups by 2027, no later than 2027. And then we're talking about 2024 for single-family houses. That's been introduced by the governor's office in their legislative priorities for this year. It's been endorsed by the state Senate, and it's held up at the Assembly. And it's one of the reasons that the budget is late this year. There's a big battle going on right now So let's stay on the edge of our seats. Hopefully we'll get to the right answer there. Bunch of other stuff involved. We're talking about a 10-time scale up of electrification of single family homes between now and 2030. So workforce development is critical. Public awareness is critical. Private financing is critical. And I'm already at my 5 minutes. So last slide. There's a lot in here, and if people are interested, I can send the public deck that goes through also, the entire suite of proposals to get where we need to get to. But what I really want to highlight here is, we think that we're ahead of the curve on this Catskill project that we're going to talk about, but we're not. Hopefully, we're not too far ahead of the curve, because we would like to see the state adopt this all-electric requirement for new construction as soon as 2024 in single-family houses. So I want to stop there, leave enough time for the rest of the presentation, and we'll talk to you again soon.
Good evening. Thank you all for being here. Thank you, Zach and the Accelerator team. We're going to have about a 25-minute presentation max. We're going to push it to that. So we're going to be for the after hour as well. Our project team, next slide there, Laura. Our project team and partners are identified here. Peter Malik and Greg Hale are principals of Regen Associates, the developer of the Catskill Project. Buck Moorhead Architect was hired as architect in 2018. Laura Carter and Remy Moorhead of BMA have been working throughout on this project. I was brought in as a partner in Regen along the way. Our valued partners in the project are kind of lined up on the bottom of the slide here. I'm going to pass this right back to Greg, who's going to discuss our mission as well as the overall site development.
Okay, next slide. And just to clarify, I've put on my Catskill Project hat. This is an outside activity. It's all approved by NYSERDA, but this is not NYSERDA, and I just need to be clear about that every time. So, coming from my job, I've been at the state for almost 10 years now, pushing for net zero. It's always been a dream of mine to actually build to net zero, and that's what we're doing here. And we're doing it on a community scale, which I think really sets us apart from many other passive house projects, at least in the Northeast. We certainly have apartment complexes that are shooting for overall carbon neutrality, but I don't know of another single family residential community that is trying to do it as an entirety. So that's what we're trying to do, trying to set the model. We'll try to educate people that this is how the future of building should work. It's hinged on passive house design. We're looking for certification, regenerative design, carbon neutrality through electrification and on-site solar generation. We've paid attention to embodied carbon. There will be a discussion of that in a few minutes. And just being as friendly to the site as we possibly can be. We have, it's actually a 40+ acre conservation area with hiking trails. We got waterfalls. It's an amazing site. Invite anybody who's interested to come up and take a look. We're using panelized construction with Benson wood. Next slide. So here's our project. If you look at the right, that's phase 1. You can see the lighter area is subdivided into 11 lots. Our model house is on one of those lots right up near the top. It's a triangular lot. There you go. That lot where the cursor is dancing now. And then the darker shaded area is the conservation area. And you can see the streams that come through and a lot of topography, a lot of falling water. Then we've got 2 more phases coming up. We've bought phase 2 already, that's in blue, and are supposed to close on phase 3 next week. So it will be a 25 lot project, about 155 acres, a little over. Next slide. And then where we are in the process right now, as Buck said, we started working on it in 2018. got our subdivision approved finally in 2021, but we were doing a lot of site work beforehand. So we built our community road, our stormwater management system, our trail system. We have completed our model house now with the site work and slab pour and the shell erection by Bensonwood, and then the finishing from the assembled house by Bensonwood. And so pretty exciting. We've closed on our first contract on lot 4. You can see that down on toward the bottom right there. Site work has begun on that. And we've just signed a second contract, which we're trying to catch up to the first one in Bensonwood, so that we're looking to have 2 house raisings this July, and then be working on finishing those houses over the next 6 to 8 months or so. And obviously actively working on selling the other houses in the lot. So next slide. So just one thing that, I think sets us apart, right? We talked about this being on a community basis. So we've actually put these restrictions into our declaration of covenants, restrictions, easements, et cetera, but this has been recorded against the whole property. So everyone needs to live by this, and it precludes fossil fuel from space heating, water heating, cooking. You're not allowed to use a fossil fuel backup generator unless it's secondary to electric battery backup. No fossil fuel powered recreational vehicles. So this is all, and actually there's another one in here. I'm not sure if it's on this page, but if you don't elect to have solar on your house, then you're required to buy 100% clean energy through a community solar or some other system. So we're really trying to figure out how we can ensure that this is in fact a carbon neutral community. So with that, that's the end of my piece of this. I believe we turn it back to Buck.
Thank you, Greg. With respect to design, that mission is the foundation of and embedded in our architectural program for the project. Modern rustic is a guiding design goal. Lots of glass open to the natural environment. We concluded very early to implement the project utilizing prefabricated panels. We decided very early to partner with Bensonwood. We did not have any sketch plan for the house at that time. We were heading toward a smaller scale house, max 2,500 square feet, 2-story, 3-bedroom, expanding into an outdoor rooms and outdoor spaces. Bensonwood has its Unity line of homes. We studied those models. We asked what the important parameters were that were to be respected when we were to consider modifications. In the studio, we tested potential plans against the Unity models. We selected the Unity VARM line, ultimately the VARM 124, as our best starting point. We then explored floor plans within that model's framework and did the same analysis in section and elevation. We assembled a presentation and made a second visit to New Hampshire where we explained this work, looking for Bensonwood's feedback with the goal to keep the project as one that worked within their existing fabrication system and had not crossed into the world of custom. It was a productive meeting. We received what I would call maybe a silver star. We had, quote, colored within the lines. Next slide. So this shows, where we started at with the various VARM model plans that we looked at. Next, Laura. Here's the VARM 124 that we used as a starting point. Next. Here are some of the iterations that we ended up taking up to show Bensonwood variations on that VARM 124. And we were looking at the same kind of questions in section also. And here's some 3D massing models showing things that we're studying again regarding this model. And we landed, the balsam is our version of the VARM model. This is our floor plan, key design modifications. We established a 2-story feature corner in the bottom left corner, which is actually the southwest. There it is. We moved the kitchen to the center. We established an L-shaped second floor, which also created a deck on that second level. We added an option for a 3-season room, which also has a second upper level deck. And we made a design decision to pitch the roof from the north edge of that building in an upward direction toward the south, rising up in the southerly direction. Next, please. And here are elevations of the balsam. And next, here are some sections where you can find that 2-story feature corner. Next. The model itself is located on an existing subdivided lot with well and septic. We sold the existing modular home for reuse. We broke up the existing slab it was on and used that in our new road construction. The model is on the same location and oriented to the south. We have built a 2-story accessory building, garage below, studio, home office, guest room above, and our PV solar array will be above the roof of that accessory building. The 2 structures together create an outdoor room which is oriented to the south and west and to a prime longer view on the slot. One of our 2 new houses will be the same balsam model with a 1-story garage with solar PV on that garage roof. We did a series of sun studies, which are there in the right-hand corner, just to make sure that the house, we minimized the house actually shading that garage roof with its solar panels. Our second new balsam house will have a ground-mounted solar array. Next slide, and I'll pass this baton to Laura, who will review some passive house details.
Yeah, so one of the great things about working with Bensonwood is that they were already really advanced in their approach to high performance buildings. So we didn't have to explain, why we want massive amounts of insulation in the walls. We didn't have to tell them what an air barrier or an ERV was, or explain why we need triple pane windows. And one of the great things about working with panelized construction in general is the opportunity to work through all of the construction details literally down to the nail months before anything is actually built. So that coordination process was really interesting because not only are you discussing and detailing for the design intent, but you also have to talk about what the fabrication equipment can and can't do. You have to keep in mind that you can't request or discuss a change to a detail in the middle of construction since it's all pre-programmed. And you have to really anticipate what your rough-in and finish contractors will need, like more than usual, because there isn't a GC just coordinating all of this as a building, goes from the ground up. So given all of these challenges to our normal process, we were really fortunate to be able to start off on the same page with Bensonwood and use their stock wall and roof assembly details. So these are things that they already had programmed into their computers, already had certified by third-party engineers, and that their workers were already used to assembling. So here you're looking at the wall and roof assemblies that we ended up with on the house. The meat of the shell, I guess, is 2x10 walls and 16-inch TJI roofs, both 24 inches on center and infilled with dense packed cellulose. Working towards the exterior, there's a 40 millimeter Styco fiberboard panel on the walls, a tapered layer of EPS on just the flat roof portion, and then zip sheathing on the roof and a SIGA membrane on the walls for our WRB layer. I do want to note that the SIGA membrane here is largely redundant regarding weather protection because the Styco is also a WRB in and of itself. But it serves as a nice protective barrier for the Styco during shipping and site assembly. It's obviously not impervious to damage itself, but gouges and rips and things are a lot easier to see on a bright blue membrane than they are on the monotone, like beige brown of the fiberboard. So before Bensonwood left the site, they could very easily just take a lap around the house and find any points of damage and tape them up. Beyond that, the rain screen siding and a standing seam metal roof complete the exteriors. On the inside, taped OSB sheathing forms the air barrier on the walls and roof, and those connect to a 10 mil poly layer under the slab. And then finally, we have 2x3 and 2x6 stud cavities on the interior to give us a nice rough-in space for plumbing and electrical, which we infilled with insulation after all that rough-in work was complete. And here are just some nice photos of our shell in production. The upper left shows a wall panel on the production line. Next to that, they're installing one of our really big corner windows in the factory. And then a few photos showing how this went from a bare slab to a weather and airtight house pretty magically in the span of just a couple days. So our PHI certifier, who has been really, really great through this process, has also been really specific about our details. One of the big specificity hurdles we had was working out thermal bridge and condensation issues with our windows. We have 8 different types of windows or doors on this house, making 16 unique head and sill connections that our certifier asked us to model. He also asked for 8 additional construction details that have nothing to do with the windows, so we had a lot of these conditions to go with. He relaxed a little bit on some of the window details that were really similar, but I think we still ended up with 15 or 16 models to do. Fortunately, we had Ed May on board. I don't know if he's here tonight, but he's a very patient and kind person and didn't seem too annoyed by the amount of details I kept sending him. So anyway, I'm happy to answer questions about why we had so many unique conditions on a relatively compact house, but I will spare the general audience for that for now. One thing I won't spare you is this specific window detail that was actually a bit of an experiment for us, and hopefully Buck doesn't mind me saying that, but it seems to be working exactly as intended. So because the windows are all installed in the panels at the factory, the exterior waterproofing layer is also completed at the factory, which is of course a critical benefit of doing construction this way. All these important systems are constructed and completed literally under one roof, and there's one point of responsibility if there's ever an issue or repair is needed. The very specific, I suppose, downside of that, at least in this case, occurs at all of our windowsills. So what you're looking at now is a detail of a typical sill from our coordination drawings. There's a bit of insulation on the interior shown in light blue, and that helps a bit, but generally there's still just a really significant bridge through the bottom of the frame shown in red. This bridge and the condensation risk it caused was having a massive negative effect on our overall heating demand value because it was happening on all 23 of our windows on the project for a total of about 115 linear feet. And if anybody spent time in PHPP, you know that's a big deal. So this was sort of single-handedly throwing us out of certification range. So we needed to find a way to insulate the bottom of the frames, but we could only put a small amount of insulation here in yellow without trapping water coming out of the weep holes. This would add a little bit of insulation to the frame, which is never a bad thing, but the size of the bridge through that bottom piece didn't actually change from doing this. So we ultimately ended up with this kind of delightfully analog solution. We took rigid Rockwell comfort board, cut it lengthwise to fit each window, and then we used a very scientific process where one person stood on the inside of the house with a window open and poured water into the bottom of the frame, and another person stood outside the house and marked exactly where the water came out of the weep holes. Then we cut small channels into the back and the bottom of the Rockwell, lined up to those marks to create little drainage pathways. So now the water drains freely, the frame gets a lot of much needed over insulation, and we were pretty much instantly back into certification range. One other quick detail I want to show here is how we address the bridges at our first floor door thresholds. So this is a first round coordination detail showing the door in the middle of the insulation layer of the wall, which puts it just off of our concrete slab. So that's the edge of the slab and our door is sitting outboard of that. We are using warm form for the slab insulation, and the initial thought was to cut down the warm form slightly and put in wood blocking there to help support it. This unfortunately would have created a very clear bridge through the wood and the concrete. Not only is this a problem for PHPP, but it just wouldn't be comfortable underfoot because you'd end up with these really cold spots on the floor every time there was a door. So our finished floor on this level is just the exposed concrete slab. So there's not even a layer of wood flooring on top of that to help warm it up a bit. So our solution to this was to pour the concrete around a high PSI block of EPS that we placed under each door, with each block being about 16 inches wider than the door, and then pulled the doors inward a bit so they rest fully on that insulation. That allowed us to cut down the warm form on the exterior so we could inset a saddle without having a big thermal bridge under the door. So that is a very rapid fire run through of just a couple details on this house, but here's where we're sitting right now. Construction is complete and we are at 9.12 for our heating demand, which is below the 9.51 threshold for low energy building certification, which is what we're aiming for here. Our last blower test was really good on the depressurization side at 0.3 ACH. Not quite as good on the pressurization side, which we think is due to a magnetic damper that didn't get installed in our range hood exhaust line. So fortunately, a pretty easy fix, all things considered. The final commissioning of the ERV will happen in about 2 weeks, and then we'll be at the mercy of that very exacting certifier. So wish us luck and come visit the house, and I will kick this back to Buck now.
Thank you, Laura. With respect to systems, we have a 1.5 ton air-to-air heat pump. It's Fujitsu in the model. We expect those to be Mitsubishi moving forward. A Zender ERV system. We have a ducted range hood exhaust, even though we are all electric with induction cooking. We constructed an insulated makeup air panel camouflaged into the siding, operated by a window operator, which will actually be a linear actuator on future builds, synced to operate simultaneously this panel via a relay switch with the range hood control. We have an electric hot water heater. We switched during the design phase from a heat pump hot water heater. We have Kramer in attendance, I hope, and hopefully he can assist us, during a deeper discussion on this during the Q&A. Next slide, Laura. Here are the mechanical plans for the first and second floor. Next slide. With respect to shading, we designed fixed shading on south windows based on evaluating their depth and sun studies. We designed a deeper system at the feature corner that provides more shading for those windows on the south, but particularly for the large west windows, we get a vertical shading from those build outs on that corner. We will track overheating this spring and summer and early fall to have more precise understanding of potential overheating. The house is unoccupied and was overheated occasionally this past summer when I walked in, but was rectified by just opening a couple of windows. Next, please. We wanted to test the resiliency of the house. In this rural area, when electrical power goes out, it might be for an hour, but once in a blue moon, it could be for a week. So we intentionally shut off the heat in mid-January this year for 6 days. We left the ERV running. We did not drain the plumbing, freaked out some people on our team or outside of our team. The weather was not fully sun. It was snow flurries, some cloudy days and the such. But as you can see through this, we had the temperature never dropped below 50. And I appreciate Kramer's help. He set this up a couple sensors in the house and put the app on my phone. And I was glued to my phone for those 6 days. Next, please. We made a decision early in the design phase that we should be thoughtful about the embodied energy in our materials. As stated earlier, our mission is rooted in regenerative design and circular economies. Bensonwood was a strong start with respect to their base wall and roof systems, wood framing, fiberboard, dense packed cellulose. Next, please. With respect to the exteriors, the siding is predominantly green local hemlock untreated. We have Coupa-Clad at the base, which is a slate product that is completely demountable and reusable and great in the snow, very much excellent in terms of its circular economy attributes. Shishugi bond in some locations, fire retardant and insect resistant. We have a metal roof, not so great with respect to embodied energy, but obviously good at keeping water out and part of the local vernacular. Our concrete slab, not so great. We're looking for a supplier with some fly ash that we can use as an additive. We have a warm form underslab insulation, which is EPS. We're looking to replace some of that with some gravel in one of our next builds. With respect to the interior, we have site harvested wood from the property, ash for flooring, cherry ceilings, soft maple around the kitchen. We use a rich light counters, which are recycled wood pulp. We have stick bulb fixtures, which use reclaimed heart pine. Next, please. We started tracking utilizing EC3 in 2019. EC3's library of materials was evolving then and probably still is now. We inputted what we knew on our end and could match in their libraries. Others are based on industry averages, which EC3 does automatically. Based on this analysis, we were 91% better than the baseline for current carbon intensity of construction for similar buildings established by the Carbon Leadership Forum. The lower spreadsheet, we used iTree to try to understand the sequestration potential of the conservation easement we've established, as well as the value of cutting as few trees as we can in developing the project's infrastructure on the lots themselves. Next slide, please. This is the EC3 spreadsheet. That was the basis of the results for the preceding slide. We still have a lot of ongoing work to do on I think, with respect to tracking the carbon. We'll just click through some. These are some interior photos just to give you a sense of how the interior showed up. Lessons learned. Our interior wood flooring had some serious problems of gapping as the unoccupied house became very dry in the winter. We are looking to adjust our milling detail for the flooring. We're going to pay more special attention to the flooring install over the concrete slab on the first floor and consider adding some humidification. We added snow guards on the roof after we had a massive snow dump that actually blocked access from the house onto our upper deck because the snow had frozen and outside there. As Laura mentioned, we are going to incorporate magnetized range hood dampers that will help us better with our pressurization air barrier tests, blower door tests. And we learned that manual operators for high awning windows can be problematic. Next, please. Future consideration, as I mentioned, we're looking to gravel for some of the replace some of the under slab EPS, fly ash concrete. We're going to be considering hot water options to optimize the hot water energy usage with respect to client use requirements and energy optimization. We want to incorporate gray water and rainwater collection into future houses. We're going to monitor the frequency of overheating, as I mentioned, this summer, and we're going to add a third temperature monitor at the second floor. We want to look over our own shoulder with respect to the embodied energy. I know we've got pH ribbons available. We haven't really checked that, but we want to check that out and eventually conduct a full LCA with respect to the project. Next. These are just BMA, other work. We do other retrofits in New York City predominantly, and we do upstate, we do some new construction and retrofit work as well. We're trying to focus on local 97 work in the city. Next. And that's it. Thank you all. And I wanted to thank again our partners here who have helped us on this project.
Let's get into the question queue. We have Daryl had two questions. Daryl, the second question I believe was answered by our good friend PH Molnaire. So hit us with one of them.
I think my first question was about, I have to remember what it was called.
Oh, hold on. I can pull it up. You keep thinking about it. Oh,
Styco fiberboard, and I think I heard that it can be a weather barrier, so the SIGA was redundant. Is that correct? So what was it desired to have redundancy, or was there another reason for using SIGA too?
Yeah, for the model home, this is actually a very active conversation that we've been having recently. So don't quote me 100% on this, but for the model home, the Stico didn't have a flame spread rating that Bensonwood was happy with, and the SIGA membrane bolstered that up. So as a WRB, it did serve a redundant purpose, but it did also protect the Styco. I believe, and this is the active conversation, so I'm not sure, but I believe that Styco has increased their flame spread resistance since this house was built. So it is truly a redundant layer at this point, but it doesn't add that much cost to the project in general. And the benefits of, being able to very quickly see damage on it and just having an extra layer of protection is worth it for us.
yeah, and I know there's different tests between the US and Germany, and so there's debates of the numbers. But again, I mean, you've got manufacturing of this product that's been going on for many years. So we just need to, honestly, I know that the testing organizations here in North America, both in Canada and the US, need to respect a little bit of what the Germans are doing. They think they've got it figured out. So sorry, Laura, that you guys are going through it. I know other wood fiber products are doing the same. But again, great use of, again, looking at the embodied carbon and fighting through the testing stuff. So great question and great answer. And again, great to see that product being used. Heading over to Zoe, I know your question got answered by Gregory, but I know you have other questions. So just give you an opportunity to ask it, because others may not have had a chance to answer it. So where are you?
Thank you. I'm good. I was just asking about whether the rock wool was okay being sort of wetted by the weep holes, but it sounds like there shouldn't be major wetting, maybe just some letting out of moisture. So if that is the case, then I think my question is answered.
Yeah, that is the case. I mean, hopefully there's never any water that ends up in your windows, but of course it happens if you get a really big rain or something. So that's I don't know. Hopefully it's always dry, but if that channel does get wet, then the rock wool is fine being wet. It's a totally inert and nothing can eat it. Mold can't grow on it. So as long as it is getting a little bit of airflow, then it's totally fine there.
Again, we haven't announced it. Sorry, Zoe, thank you for the question. That April is the theme of the month is insulation. And so I'm glad we're kind of diving into some of these questions, and the details you showed about how we can over insulate some of the things was fantastic. And so these are great questions and a great detail that we may need to bring back up in the overtime. So moving along, Jane Sanders had a question. Jane?
A related question on the windows, where the wood blocking was an issue with the thermal ridging. Did you consider using some type of a rigid foam product like Almavert or compact foam, or would that be too expensive?
We considered a couple products. At that point in the build, it was timing was the main issue. And if I recall correctly, Bensonwood has certain materials that they've already tested in terms of like what is okay to use around their doors, because they're installing the doors. We did the slab. So if I recall, it was like, what, EPS works, we know it works, and that is what we're going to use. But we did discuss Armatherm, and there was one other product, but I don't know if Buck remembers, but
I don't remember the other product, but I know that the timing for this first build, it was going, it goes into their factory and comes out like amazingly quickly. And so there's no more time. Like you just, got to do it. So this was happening the window, we were kind of analyzing our bridges and trying to get in changes and stuff as it was kind of, heading into that fabrication point. So that made it quite challenging. And the other aspect, this is not related to this specific question, but it reminded me of it, that the structure is certified by a third-party certifier. And if you make changes to that, there's a whole process of timing and as such to actually get that certification like re-upped or modified. And we were talking about some other aspect of the project for our upcoming builds, and that was an issue, was the timing of the third party, if it required a variation, and it's also a cost. You're also getting something recertified. So these are kind of interesting aspects about working in the prefabrication world, but we're super fans of it.
Well, and that's a good point. If for those that didn't attend the various prefab summits we've had, the prefab summit number 3 that featured a few weeks ago is now out there. So I'll get Zach to post that link in the chat. But again, as Buck says, is like when you're using prefab, you got to have all your ducks in a row and make sure that everything is organized, because once the prefab panels show up, if you haven't got your windows ordered, well, the project's going to be sitting and waiting. So it's great to see about scheduling and speed, and how I think all of you became logistics managers, because it's not so much about managing the project, but managing parts coming in and trades coming in. So great to see the efficiencies of offsite construction. So great points there. Rich had a question. Unfortunately, his mic and camera's not working, so I will ask this on his behalf. For the window details showing the red and green isotherm lines, what temperature are those lines? And can you show me where they became a problem for the certifier? So we're getting pretty deep. It's almost like it's a tech or construction tech, where we're diving in the technical, the technology and techniques. Maybe you can highlight that specific detail for Rick and the rest of us.
We're going to ask Greg to answer that.
I know it's because I don't want to answer that one, but I can.
I'm making
I
a
can
joke.
highlight that slide.
But that's,
I did have one architectural addition to the house, but this was not it. So I won't respond to that question.
This is the slide we're talking about, right?
I believe so, yeah. If you want to just kind of highlight that.
The certifier was mainly concerned about our condensation risk values. So these are really good windows. So it wasn't a matter of the frame being a problem or anything. It was really just we were getting these decimal points to the thousandth that were throwing PHPP off, and our certifier did not like. So we ended up having to do just this really. Again, if Ed May is on the call here, like, thank you and sorry, but a lot of these very nitty gritty, like what if we add like another 1/8 of insulation, or what if we move a piece of wood this way instead of that way? So it was these really granular moves to try and get these details to a point where, one, PHPP would work, because that's the most important thing, but also that our certifier would be like, okay, you can stop now, I'll allow it.
Again, all of us, I mean, I think most of us here really love these details, and this is kind of why we show up every week, because these are some of those small nuggets that get us from certified to non-certified, and just great to see these details. So thank you for showing these.
As is our tradition with hosts, the host will typically make share some final words to close out the first hour of the program before we go into the after hour. So Greg, we're hoping that you can maybe provide a couple of insights or some impressions from the presentation, some words for folks who need to take off after this first hour.
Sure, I'll give you a couple. First of all, again, thanks for doing all you do. It's super important. Love the support for tomorrow's announcement, and I am not the luminary. But a couple of things. So a lot of you have probably seen me around from time to time talking about this roadmap to carbon neutrality, and I talk about the benefits of passive house, and I've been talking about this for so long, and it's so exciting to live it now, and the darn thing works. You saw that slide on the passive resilience. I went up and picked the coldest night this winter to stay in the house and see all this noise about how cold climate air source heat pumps can't keep up with cold temperatures. Well, guess what? If you do the right shell, they can. I was there, it was 10 below outside, had the heating system set at 68. It got down to about 67 at 5 a.m. The concrete floor is warm because it's absorbing its temperature from the inside and holding it as thermal mass. It's not taking cold air from the outside. So it's just so exciting to see it work. And another thing that's been really exciting for us, and I don't think we can take full credit for this, but in working with Benson Wood, I think we really have pushed them. They were all about high performance anyway, but not necessarily passive house level performance. And they told us, I believe sometime last year, that they've stopped working on any project that has fossil fuel combustion because they get it. They believe in, what we all have to be doing. And, that's a lot of what we're trying to do here is set a model and bring other people along. So, I know all of you guys are already in the tent, but it's exciting to bring others in who are sort of around the edges. And that's how this movement expands and gets us where we need to get to solve our climate issues. So those are my thoughts, and thanks for having us.
Well, with that final thought, I think we all should unmute and not only give you a big cheers for making sure Benson Wood is on track with the rest of you. So Buck and Laura, let's just, everyone, cheers to these magnificent people that are putting a benchmark in.
Done.
Cheers.
And I'm gonna let that linger to make sure it lands for you, because
I'm going to mute everybody, Sean.
yeah, we can get in trouble when we do that, but I really wanted to make sure that you felt the energy from all of us, because this is really a project that just sets the benchmark for all of us to achieve. And I've been in a few of those, and this is one of the ones that I will reference to many people. If you're going to set the bar, follow what you're doing in New York. So bravo. Hopefully you get potential sales out of tonight, because I know we need to scale that development. But again, it's fantastic. So for those that do need to leave us, because it is the top of the hour, again, we're back next Wednesday, and we're also back tomorrow at 8 a.m. and 11 or 8 a.m. Pacific and 11 Eastern time. So come back for that. We still have a pretty lengthy list of questions. So hopefully you guys can stay as long as you can. If you need to leave, Laura, Buck, and Greg, you guys leave whenever you need to, but I will keep going until dinner is ready. So let's dive back into it. Just on two notes for just updates for next week. We're having another Icebox challenge in Australia. I'm going to find the link and put it in there. And then also Mark put a link in there too. If you've got a moment, vote for a contest that I'm in. I've got this fart shack going on in my dad's backyard. And of course, that's PHART for what's happening there. I appreciate your votes. Currently in first. Want to make sure that hopefully in a week's time I finish first and win a prize and be able to keep more high performance experiences continuing on. So thanks, Mark, for putting that in the chat. And let's get back into the questions. I believe, Mr. Scott Kennedy, you have the first question. I know you've got three, so start with the first one. And careful on your phone calls. A few of us can read lips, and we know what you're talking about. So careful with that. Scott, you got the floor to kick off the after hour. Scott, do you need me to unmute you? Oh, okay. So Scott's first question, he's having some tech issues. Oh no, he needs to take another phone call from one of the developers that he's trying to build a passive house multifamily for. So, okay. The first question was, again, I know we dove into the installation because that's the theme of the month, but he also wants to know what was the electric hot water heater, heat pump, or exterior heat pump, interior tank. So a couple of questions there. So maybe we just dive into the mechanical for a few minutes.
I would, Sean, is Kramer Silkworth on your, is he around tonight or not?
Kramer, Colin Kramer, where are you?
I see him.
Hello.
There you go. Okay, so this is the fun question for you, Kramer. Again, bravo to being part of this team. Again,
Thank you.
amazing work that you guys do. Maybe you want to just give us a bit of the insights on the mechanicals.
Yeah, well, so about the hot water, I think we were originally planning a heat pump water heater. Floor plans got shuffled around a little bit, and with your typical heat pump water heater, it makes a bit of noise and has to have access to some air in the building, a decent amount of air, and without a basement to work with here, trying to find a good spot on the occupied floor plans was kind of difficult there. So it got kicked down to a conventional electric water heater with some, I think the balance being made up for with like 2 or 3 extra solar panels for this one for the balance. Other options could include something like a split heat pump water heater system. I think these are being considered as upgrades for future models of the house, depending on the size of the family living there and how much hot water they're going to need. So any electrical option is going to be on the table here. You just have to think about the other elements of the noise and airflow requirements and upfront costs, all the usual stuff.
Out of curiosity, did it affect your energy model? Like that's the thing that I read a study where they were actually trying to measure. I think it's done in Massachusetts. It was done in the cold U.S., North cold U.S. somewhere, but it was suggesting that I think they were, standard built houses. They weren't passive house buildings, but they actually couldn't measure the energy consumption difference between whether the heat pump was inside or outside. I thought that was interesting. And so we're always struggling with that question. We've been putting them in parkades, and we got one. In fact, the phone call I took was from the building inspector on one where we're trying to put them in a garage. So Sean will like this. We just got a project out of LEC and got heat pumps in the garage for hot water and heat pumps for heating and cooling. So Sean knows this project, but yeah. So that's what that was about. The other thing, I had another question. I'm trying to remember what it was, but since I joined you here, the other one was we're working on a passive house, and I have great concerns about large amounts of refrigerants in our building because of the global warming potential of them. And so we're starting to look at, can we and should we be distributing the energy within the building using water rather than refrigerants? And I'm wondering if you guys had considered that in your project. I am considering it in a couple of projects right now. So we would use a monoblock heat pump outside. Now, I'm not in as cold a climate as you guys are, but we were going to use a monoblock heat pump outside, and then it would be running glycol that would go into the building where we'd have a heat exchanger, and then we would actually pipe all the energy around, whether it's heating or cooling energy, using water. And I'm curious if you guys looked at those kinds of options.
I'm very excited to see what's coming on the horizons for these air to water systems. This house being fairly small, it's only 1.5 ton system. I don't think there's anything that small in air to water yet. And it's also a single zone system. So yes, it's refrigerant based. And I share your concerns with the GWP of these systems and the eventual leakage of all of them. So I'm very excited to see what's coming for air to water. I don't think we're quite there yet with the technology, particularly at the super small scale. But that is something we're going to be seeing more of for sure. And refrigerants are changing also. So yeah, I don't love heat pumps. They're not perfect, but it's looking good.
Yeah, we're looking at
NYSERDA too. But more for larger buildings. And, it's really important to try to do that when you're looking at a VRF system where you got refrigerant flowing all through the building. We got a very short run of refrigerant here. It just goes to our internal air handler, and then that's all forced air from that. So it's not running refrigerants any further into the building.
Yeah, so this is the big dilemma that we're in on everything. But I'm looking at it on a little project, but it's the space pack heat pump. It's a 3-ton, but it's inverter based. It's actually a Mitsubishi unit, and that's the one I'm considering putting in. And I got a 5-ton that I'm considering putting into my old leaky 1912 house, but same reason. Yeah. I had one more question, if I could be so bold, Sean.
You could, Scott, but there's going to be.
I was looking at the window, the over insulation details on the window, and I love those details. I took a screenshot of them because they are all the things we struggle with. And I noticed that the metal cladding on the outside of the window actually goes behind the over insulation. And I know we've been talking to one of the window manufacturers about getting that cladding cut at that point, so you don't get that thermal bridge back behind the windows. And I wondered if you guys had ever talked about that with your window supplier.
Yes. And in fact, that detail, I wondered if somebody was going to ask about that, but we did not install the metal sills. So the way that Bensonwood works is they obviously install the window itself and then waterproof anything. And then the sill, I believe they would just give us like the coil at, like 20 or 24 foot long pieces. And then we just cut it to length on site. So we just didn't do that.
What I was actually referring to was actually the cladding on the window itself.
Oh,
so,
right.
So that cladding, and then that metal cladding goes behind your, over insulation at your jambs and at your head and at your sill. And I was just curious as to whether, we're struggling, right? We have the same issues on a bunch of stuff we're doing, but we got a little milder climate here in Vancouver, so we're not tending to worry about it too much. But I do have a northern project. Unfortunately, it's probably a 30 kilowatt hour building, not a 15, but because our windows are triple glazed but fairly stock frames, but vinyl frames. Well, we're going to over insulate those on the inside because they're outward opening. But I've been talking to one of the manufacturers about actually cutting that cladding. They can provide it to us cut if you want to over insulate the frame. So I was just curious if you had that kind of discussion.
That's a great idea. That didn't come up with this particular project, but I promise you I will be emailing Bensonwood tomorrow morning about it to see if we can.
It would certainly help your. I don't know if Ed May could tell you what the difference is, but I bet you it would help your model a little bit. Anyways.
I am sure it would. Yeah.
Scott,
thanks, Sean.
Always great questions. And again, just to reiterate James's comment here again, is as we're trying to save the planet or save the human race, anything we can do now will have benefits. And so the fact that we can get to dealing with electrification, we can kind of postpone the refrigerant discussion until we have better solutions. But it's that tricky part. Just to give some people an idea, is on a couple of projects where they have switched over to heat pumps, the builder and the client are aware that if the refrigerant does leak, that's about 7 years of them running their fossil fuel current energy source. So they're aware that, hey, they switched off to a heat pump, they're doing well, and as long as that refrigerant is leaked, they're doing okay for saving the planet. So, but again, it's in those climates where the operating energy is dirtier, we need to consider those different things. So, again, awareness is key. So thanks, James, for bringing that point on. Lots of great questions. We'll get to them, folks. Again, hopefully Buck and Laura and Greg will stay as long as they can. We'll get to it. Next in the queue was Bronwyn. I think Bronwyn jumped off. I had her question queued up and then I just lost it. So, sorry. Was there a specific reason for targeting low energy building instead of passive house? You may have mentioned it, but just to reiterate what that answer was, please.
We couldn't reach passive house. We were, the building was so, right, Laura? That's correct. I mean, the building is small and we have like enough exterior surface wall area that we were not in the vicinity of 4.75. And without beginning to go to extraordinary insulation levels. We have we're R80 at the roof and R55 or so at the wall. That's solidly good. So we were fine just heading for low energy building for this house.
And this may be heresy on this call, but at least my primary focus was carbon neutrality, not achieving a specific level of certification. So extremely low energy usage and supplying, making it all electric systems and supplying the required energy from clean energy sources. So the more we can push it down, the easier it is to accomplish the other two goals. But like Buck said, we just couldn't get there with this design at a cost-effective price point.
Yeah, and I think we all just appreciate the detail of what you've done, where again, you realized, oh, hey, in the process, we're going to knock down some trees. How can we use that beautiful lumber for future details? I mean, again, I think we all appreciate just the level and awareness you have. And so when we bring up these questions, you can defend it because you have gone down to the nitty gritty of it all. So again, I think this project's phenomenal. So keep this thing going. Next in the queue, sorry, I'm not up to speed. I'm keeping these going. Jeff X had a question about hemlock. Jeff, where are you at?
Yeah, hey guys, how you doing? So my question is, why hemlock?
So I'll answer that. So hemlock is a local material that shows up throughout the region on all of the barns. And I did see a point, Jeff. I think you had said something. There was some standard or some testing or whatever regarding lumber that you cited. And by coincidence, I was talking earlier this week or late last week with the miller, the company that mills our wood. And we were talking about that wood, and somehow we were talking about the hemlock rain screen. And I just said how I liked it. I liked it because it's around the region and all the old barns. I mean, it's lasting for decades on the barns. And he said, this fellow said that, he said, it's interesting with hemlock because the books, like the studies, show that it's not supposed to. Like, it's not supposed to work. Yet here we're walking around and it's working. It's on all the old barns. It's 50 years old. It's 100 years old. And it's there. It doesn't work. I will tell from my own experience on a deck horizontally, it rots right away. But with this being vertical and what this fellow taught me, which I didn't
I thought I saw a lot of horizontal on there as well. Your detail was horizontal.
It's horizontal, but I'm saying it's vertical in space. It's laid horizontally, but it's vertical. It's not like,
oh, it's on a vertical plane, right? I get
you're walking on.
Yeah,
right. It's vertical. Plane. Right. Okay.
It's there, so it can dry out. And this guy said, he said the best way to put it up is if you put the heartwood out. Like, that's the strongest. If you look at the grain and you put the heartwood out, that's the best thing. But there's an old barn restore fellow in our region, and he was at our opening in the fall, and I walked him through this detail, and I said, listen, we got a rain screen. It's hemlock. We're not treating it like how long are we good for here? He said 100 years.
Yeah.
And so it just doesn't fit, Jeff. And if I didn't have this conversation with the mill guy, I would have read your thing like, oh, it's not supposed to work. I would have been freaked out. I'm not freaked out though, because the mill guy confirmed, that those studies aren't, necessarily 100% accurate.
Right. I probably use the same mill guys you do. Okay, so I'm going to have to do some experiments with that because I'm a wood science guy from the age of 10. The database I posted, by the way, is probably the best wood database in the world. The original book actually had wood slices in it, but I'm going to have to relook that because I do a lot of wood houses, and I'm kind of a wood house freak. The detail on a wood house literally means the difference between it lasting 100 years and lasting 10. The details that you use. But I was really kind of curious about hemlock. I'd heard the similar thing, but I'd never seen the science that backed it. So I'm really going to have to do some experimenting on my own here.
Well, you can use our house as an experiment.
There you go. Hey, and
Well,
just
I want to test the destruction. That's what I want to do. And I ain't gonna do that on your house, buddy.
well, Jeff, I can tell you this. I was in Germany about 10 years ago and we did a tour, and one of the professors at Rosenheim, which is one of the most prestigious wood science building universities in the world, said that wood works like this. Depending on the degree of how you've installed it is the age of how it will last. So if you've got it 90 degrees, that's 99 years. Every which way this reduces it. So really, when wood's flat this way, 0 years, unless you stain it and protective. But once you go this, you're adding to the lifetime of it. And that's where you'll see beautiful siding installed where they don't even stain it, and they might replace it, you know, in 20, 30 years as it goes from the beautiful wood to the patina to the gray. And then they just let the gray go until, you know, it falls off and they replace it. But I mean, I was in Germany and I've seen 250-year-old wood siding where they've got again the fish shingles installed, and it's priceless. So again, doesn't matter the material. That was the rule of thumb of a professor that is, you know, again, someone that you would respect a lot. So
Yeah, I mean, I look, I don't want to. I traveled in those circles for a little while, and you're right about that, but it's also very, very, very dependent on the properties of the wood itself. So you're right to a point. That's all I'm going to say.
perfect.
So, but yeah, and by the way, the wood they use in Germany is larch, Siberian larch mostly, just so you know, exterior. But thanks, guys. Really appreciate that that information, Buck. I really do. Thank you.
Thank you for the question.
All right, Jeff, moving on, we have Susan who's got a bunch of questions. So Susan, which one of the plethora that you put in there that you want to ask this amazing presenters? Over to
Well,
you.
Scott got lots of questions. How come I only get one? Okay,
I know you're sneaky like Scott, and so I
no,
just
I'm
have
not
to
as
say
clever
it,
as Scott.
and
No,
you know what we're gonna get at you. Go ahead.
Oh, I got one simple question. What were the windows that you used? I must have missed that. Maybe which windows? If I could ask.
They are, yeah, they're Unilux brand.
Oh, interesting. Thank you. And then my sneaky question is about, okay, and it's not, I understand this is a bigger question for everybody. It's really, you know, when I see these large lots and pieces of land, and that we are forced by, you know, the way the zoning is done to build these single family houses. And my question becomes, you know, what are our thoughts on that, about building a single family house, when we all know, everyone on the call, that it's the multifamily that we need to be moving towards? No one has to answer that. I can just.
No, this one I think is great because. Oh, sorry, go ahead, Buck.
Well, I was going to say, yeah, we definitely want to answer that. It's a great question, and you know, the reason is that you know, this town, I don't think has any zoning districts with multifamily. It's a very rural zone, but it's undergoing a lot of development pressure. So people are going to build single family houses. They're going to build them. They're going to be built. There's a lot of them being built, and so, you know, what we want to do is model that development, you know, of how do you build it, and we've done it in a way, and Greg was speaking to it, you know, eloquently at the beginning, you know, with the HOA, and it looks effectively like a cluster development, though they didn't permit cluster developments, but we've minimized the disturbance within the forest. We're cutting down as few trees as we can, and we're going to prevent clear cutting that forest down. So we've got a lot of carbon capture existing. So we're trying to model, like, if you're going to have single family, this is a way to do it. We're trying to set that up, and because it's going to happen. Like, so.
Right. You might as well do it right if you can, right? Thank you. That's a great answer. Last question. I know I'm not allowed, but it's the Harvey question. I got to do it. Sean.
Go for it.
In Canadian, eh?
Off.
In Canadian, how many dollars per square foot, eh? Don't have to answer that.
No worries, okay. Buck and Gray, you respond by giving the answer in dollars per meter squared, so then everyone has to go figure it out as they go get a bunch of groceries.
That's fine.
I was reading the chat. I'm sorry. Was the question about cost?
Of course.
Yeah.
Oh my
Yes.
God. Well, we have, I wish we should have a better answer as to what it costs per square foot. Because
No,
that,
the answer here, well, maybe Greg wants to chime in, but I'll give it to Susan like we give it to everyone else. It's the cost of doing right.
That much?
It's
Ooh.
exactly that much, the cost of doing it right. But sorry, Buck, if you do have an answer, let's give it to her. But
yeah, I mean, we're struggling with, we built the model, we were pricing it pre-pandemic, and we built this model during the pandemic, 2020, it was into construction. So it was a struggle getting it executed. And it's very hard for, going forward, we're having a hard time identifying our construction costs. I mean, it's moving around a lot.
Yeah, we could say that it was it's probably over $300 a square foot for what we built. And there's no way we can match that or get anywhere close to that with what we're seeing today from all of the different suppliers. It's really shocking, the increase between 2 years ago and bidding these next two houses out today. I mean, we're looking at 30-40%. I mean, ridiculous price increases that we just had. It's a shock to our business model. The houses are not going to be cheap. Getting back to your other question, Susan, I totally get it. When I'm running around NYSERDA, we spend a bunch of time on affordable housing, and frankly, affordable multifamily housing is on the cutting edge of carbon neutral development. So that's really cool, but we will continue to have single family development. The zoning here didn't let us do smaller. We did try to do a cluster to start, and they said, oh, well, you've got to put in a community wastewater system and a community potable water system, and that just blew the economics totally away. So we frankly bought the land first, Peter and I, because it was so spectacular. We did everything backwards here, and then came up with, okay, well, how are we going to build it out? And this was the largest number of houses we could get on this first parcel of 90 acres, and the other parcels were already subdivided. So they came as 4 to 5 acre parcels. So yeah, affordable housing is critical. When Regen goes out and does its next project, maybe we can do an adaptive reuse someplace and get to much more density.
Mm-hmm. So it sounds to me like that the question of the pricing actually is a really important question given where we are now. What's been happening. So yeah, thank you. Anyway, fantastic. Thank you very much for sharing. Wonderful work.
And Greg, I love how you say, because we do this all the time, where you're saying you did it backwards. And I have to say, no, you did it the right way. The way you're developing this property, the way that you are looking after it with intention and integrity to make sure that some other developer came in and then cut down all the trees and built barely code buildings. The fact that you came in and get almost passive house and are aware of how close you are away from passive house. Then you looked at the embodied carbon. Then you looked at making electrified. And then you have a plan for solar panels to get to zero carbon. I'm sorry, you did it the right way. And from all of us, we follow you and will continue to follow this project. And again, I can't say enough. I hope that one of us out of the 120 people who showed up today start lining up at your doorstep to buy a couple of these, because the property and area looks fantastic. And if I was closer on the East Coast, I would even look at this property, but my carbon footprint to fly there once a year to enjoy the space just kills it all. So I'll stay here in Vancouver, but I appreciate how we talk about the, and I'm sorry, I'm kind of going on a bit of a soapbox from James, but he inspired me to just talk about how, we need to change, we need to do things our way, because our way is the right way. So
that's true. That's true. It's backwards from, I spent a bunch of time in real estate in my earlier career, and we're doing it backwards from that perspective, right? We didn't come in with a business model and then say, what can we build for this price? We came in and said, we're going to do this carbon neutral. That's the first and foremost thing. And then things have just flowed from that.
And I mean, most people that are here today, I mean, you skipped over quickly because we love the nuggets of the pacifist details. But again, the promotional materials of the interior space, it's gorgeous. And that's going to capture a lot of people that share what you're doing. And then when we get into the high performance geeks like us, or the beautiful nerds, as Monty calls us, you know, we all will appreciate these details. So
yeah, Buck and team did a fantastic design job here. I couldn't like it more.
Okay, well, I'm sorry I went on a rant. Peter Molnar, you're next in the queue. Hopefully, Peter, you remember your question because it's somewhere here and I got to gather the rest of them. So Peter, over to you.
Yeah, for the rain weeping holes under the windows, instead of just cutting, as you did, a little channel when you found it in the rock wall, could a fiberglass tube be put there to actually lead in the channel that you cut? So it just keeps it direct from the window to the exterior.
I'm sure it could. As I mentioned, this was it's actually funny. It was Buck and I just sort of standing there thinking, we were on site looking at this shell, wondering how do we get insulation on these things, and we just started, pouring window in. So this was really an experiment, and I'm super excited to see where this detail goes with the next house and the one after that. And I would love it if it were some sort of like really formal, like tight, clean detail that we can brag about a little bit more. But that's a great idea. So yeah.
Well, even too, your idea is braggable as well. I mean, I took a screenshot too, and we're gonna discuss it as well, because the fact you just put a slot to ensure that water doesn't have to whip through the material, that it actually does have flow. A lot of times people put, mesh, 1/4-inch mesh. So you've given it, but you've kind of told water where to go, and you've got gravity on your side as well. So anyhow, great question, Peter. And some of the things you guys have gone through is great. So sorry, moving along. Okay, Scott Kennedy, I think you asked all your questions, so I'll give you a second to chime in as I queue up Brian Keach. Scott, are you good on your questions? I think that's a yes from him. So Brian's question was, again, getting back to the windows, which again, we love so much. Regarding the windowsill over insulation detail, did you also need to over insulate the window head and jambs? And I think the answer is yes, but Laura, I'll let you clarify.
Yes, the answer is yes, but that one, I don't know that I have a good picture of just the detail, but I'm going to share that real quick.
Yeah.
So if I can, I don't know if I can zoom in on this, but where my cursor is, so this is our typical window head. And so this does have a fair amount of over insulation on it already. So the head was actually quite easy. The reason the sill was so problematic was just because of the drainage. Also, if you're looking at the sill detail, Bensonwood's standard process is they add this little extra, like a sub-sill piece on there. They have a good reason for it, which I don't quite remember, but I think I think actually it helps them get insulation on the inside of the window frame in this area, but it made it even that much farther from where they do their waterproofing layer to where we wanted to be. So it was just much trickier, given where the waterproofing layer was in relation to where the actual part of the window was that you don't want to cover up.
Yeah, great stuff. And I'm seeing that a lot of our projects now too, is where we leave the rough openings from what the architect gives on the sides, the jambs and the heads as that 1/2-inch space, and then we do another extra inch on the sill just to put in insulation, or maybe even sometimes wood, just so on the outside we can get a proper slope, because we're now recessing the window in from going from flange to double pane windows to high performance windows. We're moving that window to align things properly. So great. Again, I think all of us have screen saved that slide deck. That slide. Great stuff, Laura.
This is Brian. I wanted to follow
Oh,
up
there,
with one
Brian.
thing.
Great.
Yeah,
Go ahead.
excuse me. Is there a measurable difference in the amount of thermal bridging that you eliminated by doing that detail?
Yes, significantly. I don't recall the numbers offhand, but we sort of discovered that this was a problem after the shell was already assembled on site. So our PHPP at that point is like fully developed, and we think we know where we're going to end up. And then in conversations with the certifier, he's like, no, you gotta roll this back a little bit. So I actually don't recall where we were with PHPP before we knew this was a problem, and then after it was modeled problematically, and then after we fixed it. But my recollection is that it was like multiple digits of difference just in this window sill over insulation thing. Like if we ended up at 9.12, just hypothetically, we might have been at, I don't know, 12 without this extra insulation there. So it was really significant.
Okay, thank you.
So yeah, Brian, to confuse you with metrics, because I'm in the kilowatt per hour, not in the BTU, is again, it could be about a 10% difference. And so depending on the units, it's either 5 or 10 numbers. And so when you're trying to get close to passive house numbers, these, small thermal bridges matter. And I think, if you wait till next month where we focus on windows, we're going to have a bunch of our Windows sponsors come in and talk about these details, because, we're having fun nerding out tonight. Wait till next month when we dive into it. And like, as Scott alluded to, as well as when window companies don't know issues and we're asking them to modify their windows to help us out because we know that they've got issues. And so it's like, yeah, we want to hack off an inch of your aluminum on the bottom of the window because it affects the thermal performance of your window. And like, how do you guys know that? You're like, if you don't know Ed May, you should know him because he's the one that told all of us that piece of aluminum is causing a ruckus and we need to fix it. So again, great detail. So Nitin had a question, and I don't believe it can be answered. So I will ask it. So it's air source heat pump and Zender's ERVs. Buck, can you specify the models if you don't mind? Because they want to copy it and paste into their project. So Buck, do you have the models, or I'm not sure if Buck left, so maybe Laura.
I'm here, but I'm not sure I'm the right person to. I'd be taking a guess at the Zender. I think is a 350 Zender. I'm not sure if it's got more.
It's actually not. It's the Zender Q. So I didn't do it. Kramer specified the 350 when we first started to work out this project, and then Zender came out with the Q, and Kramer's like, you gotta switch to the latest and greatest. So it is the Q350, I think is technically what it is.
And Laura or Kramer, can you specify the air source heat pump?
It is a Mitsubishi.
It's a Fujitsu on the model house, but we're moving to a Mitsubishi.
True. Okay, so I shouldn't answer that question.
Okay, hey, it is a team effort in everything.
I can answer other ones.
All good. And we come back to the price as well as the first house is, yes, the presentation model, but it's also the mock-up. And so we have to consider there's a mock-up fee for some of this as well as we move, as you move into full production. And so I kind of look at that first project as, yes, it's the marketing engine for you, but for all of us that we talk about mock-ups, we love a good mock-up, and that's a beautiful mock-up. All right, moving along here. Again, I'm just going through the chat. Eric had a couple of questions. Eric, do you want to fire away? I just got you.
I was also just excited about all the detail work, and I realized that everything's a system and has to work together. And there's a couple opportunities. One opportunity I missed on my personal place, and one opportunity that I'm excited about. The one I missed is I just went with a resistive hot water heater instead of the heat pump water heater, and I've changed that recently, and I'm now running about a third of the energy as I was. But the other thing I realized is that my water heater is well oversized because just using the typical code stuff around here, It has a software issue, and it went off for a couple of days, and we didn't notice. So, but the intent originally was to put it in the garage and have it run at say 5, 6, 7, 8 at night, right? So it picks up the heat off the cars. So I was wondering if there's a controls opportunity there if y'all were putting something in the garage. Somebody talked about putting one in the garage or outside. The other thing is I'm really excited about my geothermal unit, and it's come up a couple times here effectively. So I'm out in the woods too, so no fan noise. All the refrigerants inside the box, so not a lot of it, not a whole lot of chance for leaks. No site built refrigerant plumbing, nothing like that. And that site looked like it had a lot of grade to it. So you're doing excavation and other things anyway. I wonder if that implies that the ground source heat pump would be easier. And water to water, you can get them reasonably small. I don't know, just bring out some discussion points. So no real question.
Fair enough. Yeah, I know the geothermal is always interesting, but I know here in BC, typically the cost of it means you need 4 houses to make it work. And so on this particular small scale, that's super efficient. I think really the heat pump is really the driver. Regarding the point about the garage, that was with Scott Kennedy in multifamily about putting it in their garage units, just from a space standpoint. But I think I'm not sure if Kramer's still here, but I think if I could defend him on his decisions for it is, again, you know, you're talking about a high performance building that's 90% more energy efficient than a standard house. And so the loads are just so small, and realistically the equipment they're putting in is even oversized because in North America we don't have the right equipment because of how small we're getting on these loads. So Kramer, does that help justify or answer some of those questions?
Yeah, I think he just answered in the chat that geothermal is overkill from his perspective for this house. One thing I'd just like to mention is it does look like we will get a New York State tax credit for geothermal passed in this session for it'll be a $5,000 state tax credit. Can't imagine that the governor would not sign that bill. So that's at least one good thing the legislature's stepping up with this term.
Well, and then the rest of the good news, you're just going to have to wait till tomorrow morning to hear about other good news. So I'm going to pin that, Kramer, and we're going to talk about it tomorrow. So moving along. Oh, sorry, go ahead, Eric.
And I picked the geothermal not just for the energy efficiency, et cetera, but it is also, I plan to live here till I die. So it's low maintenance and no fan noise out here in the woods.
I saw most of it.
Yeah, I hear that, and we'll probably study it again and look at the cost comparison with the all of the tax incentives that are available now. I agree, it's definitely longer lived, and you know, the more we do electrification with geothermal as a state versus air source, you know, you get higher COPs, which means lower overall impact on the grid. We are going to be increasing our peak demand by the mid 30s. It'll be winter peak instead of a summer peak. And, you know, how much higher depends on how we electrify. So I'm certainly I'm a believer in geothermal, but in this case, the air source really works well as well.
Yeah. And again, you know, we're all searching for that great, perfect solution. But again, as even James alluded to, is at this point, we do need to just get to pretty good as we get towards excellent. And if we get to 80% instead of 100%, we're going to be better off. So I know we're all overachievers. We like to get straight A's, but sometimes, as my mom said, a B is okay. You know, we're working hard to achieve it. And the best part is we get these projects out to the open. And as a group here, we're doing today, you know, as a collective, we're debating about how more efficient or other things that they could be doing. But at this point, we need more of us doing more of these versus the code stuff. So again, pat ourselves on the back for being innovators, for fighting in a niche market, and then being able to present some good things, because we know we could do better, but the cost of it and what's available today, all those kinds of things is. But as you can see, even talking about window details, of going up to a window detail and collaborating and be like, hey, how do we make this a little bit better? well, what they presented was pretty cool. And that was just about, looking at a specific thing. So I've got to
your mom talk to my mom, because she never told me B was okay.
Well, yeah.
Just saying.
Well, my mom saw the sleepless nights and maybe the other fatigues points and was like, you know what, you're maybe working too hard for those A's. But anyhow, that's a separate conversation over beers that we definitely can have that are long overdue. Moving along, Jane Sanders, you had a question or a comment. I can't tell right now because there's just 20 messages deep here, but I see you're next. So Jane, what do you have to?
Oh, actually, Kramer answered it in the chat, and
Okay.
someone else asked the same thing, just why the switch from Fujitsu to Mitsubishi.
Okay. All right, moving along again. Thanks, Jane, for joining us. You're doing amazing work as well. And again, it's great to just, the 57 people are still here. I know you're all doing great work, and I appreciate you all joining us well after the first presentation. Sorry, I'm going through. Barbara, did you have a question? Thanks again for joining us we don't even know what time it is in Australia. So maybe you can tell us what time it is, because we can't figure it out.
At the moment, 11:45 in the morning.
All right. Well,
Because,
hopefully your Thursday is going well. Give us the scoop.
So
What's going
far,
on?
so good. Yeah. Look, I have a question about green roofs and photovoltaics. This is my current passion because I'm designing I'm going to knock down my house, put up a house with a skillion roof, have a green roof, and I want photovoltaics above the green roof, because a bio-solar roof, the photovoltaics work better because they keep the temperature of the photovoltaics within the operating parameter. Especially here in Canberra, it'll get to 40 degrees, 43 degrees in the summer. And if the photovoltaics cut out, I'm in trouble. The other thing is, of course, the green roof adds insulation and controls water flow. So thinking of that perhaps for the future?
We haven't, can you hear me, Barbara, there?
I can,
Yeah.
yes.
Okay. Yeah, no, I will say we haven't had any conversations about that. We do a lot of roofing work in the city, and I've haven't put on a green roof specifically, and I know there are removable systems, and there are a lot of complications with adding green roofs or trying to do it. But I say all that, but I would love to learn more as you explore that, because I wasn't aware about the temperature or improving the PV performance and all of that. So I'd love to know what you're doing as you move forward with that.
Cool. Okay. Let's see if I can post a link to an article that was done recently. Thanks.
Yep.
All right, everybody. I think we've gotten through all the questions. Bob, you had one that I don't quite think was answered, but I know it's window related. So why don't you fire it up? I think we're good. Maybe anyone else have any questions, raise your hand, because we're getting to almost 2 hours deep into this. So I think we're good, but go ahead, Bob.
Can you hear me?
Yeah.
Okay, great. So in window installations, we've taken drastic steps about how to create, control the condensation under the pan flashing. And so I've tried the cotton weep ropes, only to find out that a high velocity wind-driven rain can actually go through the weep rope and actually squirt water into your house up and over your pan flashing. Because we've tested it, and it's surprising how it's actually a hose going through the cotton weep rope. Because oftentimes when we do pan flashings, we'll run a cotton weep rope along the interior of the turn up of the pan flashing of a door, and they have it poke out on the sides. Okay, so we're trying to control that, but then in other conditions, we've also used actually like a baby blanket made out of fleece under our pan flashing to try to control that upward vapor, and then have it overlap onto the WRB within the rain screen to try to mitigate that. And so far, no news is good news, right? So it's been 5 years since we did that, and I've done that a handful of times. But it's like the plastics that are fleece, wick moisture, cotton rope wicks moisture, but synthetic rope does not wick moisture. Okay, so there's a whole world of that materials to understand. Anyway, it's just interesting to see how we can incorporate materials in different places to do these different jobs. You know, thin, thick, round, whatever, you know, all these different shapes to deal with. It's just a footnote to your point about, you know, cutting a hole in the rock wall to drain the water, but you know, we're also exposing the building in some respects to the, you know, the opposing forces of nature, you know. Anyway, little rabbit hole, but we're always experimenting.
A good rabbit hole though. I'll look that stuff up. That's really interesting.
So always trying to figure out how to maintain, because we get these doors on, like, you walk out on a balcony roof, and some of these, you know, a lot of contractors don't give you the curb so you can prevent ice damming, because we're in Chicago and we get -10 to 110 degrees, right? So, and the extreme temperatures and the wind velocity and the wind driven rain. So how can we develop these products, you know, use other materials to do both things, you know, keep wind driven rain from coming in there and get the water to drain out. So, and it's a huge issue.
Yeah, interesting point, Bob. And again, in this particular project, climate zone wise, they might not be getting as much of the wind and rain because the way that the, you know, the location in this and the trees and the forests are helping to reduce that. So you might not get, and then you also have gravity with the slope sill that they've got. So it may not be as big of an issue on these particular projects because your projects are like right in the city where you're getting it, and you also don't have nice sill details to help stop the bulk water from, you know, going backwards. So I think that's a little bit of a different in this particular section, but maybe Laura, if you want to comment, go for it.
It might not be as windy as Chicago, but we get some incredible winds up there. We've had bomb cyclones that have just, we got there when we bought the property, there was like a football field size just area of blowdown. You could tell it was like a mini cyclone, just wiped out all the trees. So we get those events.
All right, so I'm wrong, and Bob, again, things to be aware of. So good points to bring up. But again, this is the details, right? You know, we're looking at those millimeter or eighth of an inch kind of things that, you know, we're critiquing of to ensure that as we're building high performance, that we're, you know, we have to be more critical about the building science and ensure that, you know, all these fundamental details have you know, a little bit more of like the belts and suspenders approach, where we've got 1 and 2, maybe even, you know, tertiary details so that we don't have potential leaks. And, you know, I think in this particular case, you know, they've definitely gone over. And again, you know, when you have multiple eyes on, you have a little bit of that integrated design process and or integrated design planning, that a lot of these details get, you know, taken care of, and you know, we kind of maybe and sometimes overthink them. But you're right, Bob, in your world where people never thought about details and you're fixing buildings in your Chicago neighborhood, you know, you're having to overthink, you know, 100 years worth of bad decisions to try to rectify things. So you definitely have seen more bad building efforts than probably we have.
Yeah, I just could add one thing to it. I think that this whole discussion about the window detailing and that sill, you know, the beauty of a rain screen is, I've made so many mistakes in my career, which included not using not even knowing about rain screens for decades. Like that, having a separate, there was a question in the chat, like our drainage plane is that, you know, fiberboard with the fabric membrane on it. That's the water drainage plane of the house. So the rain screen is proud of that. It's vented, but that rain screen keeps, you know, 97% of the water, hypothetically, or something like that, away from that drainage plane. So that is all, you know, that's a redundancy effectively. Most of the water is not getting back to the drainage plane. At that windowsill, we've got a Shishuggi bond sloped wood sill that's on top of that insulation. So that's like primary, that's like a drainage plane effectively. The rock wool, that's a drainage plane. That dense rock wool, that's acting as like a drainage on a slope. And then that's taking most of the water until you get to our drainage plane, which is what's that slots on top of. So it's got like, I'm going to knock on wood because, you know, after all that, there'll probably be a freaking leak somewhere. But, you know, we're doing everything we can do.
Well, Buck, I knocked on wood for you as well, but the fact again, like you just described, how you have, you know, a caulking bead wood that is burnt. So I mean, that wood now, it should last 100+ years, because you've got Japanese buildings that are 1,000 years old that have used that technique. So I think you got a pretty bomber sill detail. And I mean, I would even say that you either choose a metal flashing or that particular sill, and in your climate, it's pretty good. And for those that don't understand furring strips or rain screen, come to Vancouver in the 90s where we had the leaky condo issue. And so here in Vancouver, we know furring strips and rain screen. So bomber approach to what you guys are up to there. So
You guys mind if I jump in real quick?
go real quick and then we'll wrap up.
Barbara and Oz, okay, with the low slope roof and the green roof detail, we're trying something new on a building on the south side of Chicago where we want to vent the roof system, but yet we're not opening up the roof for ventilation because part of the roof is open cell foam, which we've proved that we can actually ventilate and pull the moisture out of it, and the rest of the roof is just it's an old, you know, continuous pitch roof. So what we're doing is we're taking dimple board. You guys understand, you know, the term dimple board is for foundation drainage, right? So we're coupling dimple board on top of the roof sheathing and then putting a high density 1/2-inch polyiso on top of that. So we're creating like a heat exchanger over the top of the space sheathing. And then we bring that up on the parapet walls. We're venting it out through our vented flashing of the stones so that we've got this boat, like this U shape, and then it flattens out. So what happens is that when you get pressure differentials in the wind, it creates negative pressure. It sucks all the moisture out of the roof system, but doesn't compromise the roof. So you might want to consider something like that for a green roof as a base for your green roof. Just FYI, that's all.
Yeah, so may I respond to that?
Yeah, sure.
A warm roof, if you insulate just below the roof panel, and then you put on the final roofing, and then you put on the waterproof, and then you put on the thing that prevents the soil from sinking through and blah, 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 blah. A warm roof is the way I'm planning to go.
So my only thing to that, Barbara, is when you say a warm roof, just make sure that, again, the vapor control layer is on the warm side of the wall or the roof.
Yes.
So as long as we leave you with that, you can call it a warm roof, a solid roof, a green roof, but I'll leave you with that.
Yeah, no. So airtight and then vapor control.
Yeah. Yeah.
Exactly.
And then
vapor control.
Yeah.
And then your roof membrane on top of your. So that's how we've been doing all of our, you know, along those lines. That's how we've been doing all our flat roof systems, and the entire structure dries out from just wind pressure swirling around.
Right. Yeah. Okay.
Anyway, it's an important detail because those failures are colossal. They're not.
It is. Throw your email into the chat so I can write to you about this.
Yeah,
Sure,
Bob,
I'd be glad to.
And it's funny, Bob, because here in Vancouver, when everyone says a flat roof, I'm like, no, there's no such thing as a flat roof. There's a 3-degree roof. That's as flat as we go. That's where we get to. There's no such thing as a flat roof, because flat roofs cause trouble. Anywhere where there's water will bounce out. All right. Well, sorry, Laura, I got one last question. I didn't ask it correctly for Rick. He wanted to know, again, in those therm models of it, the red line and the blue line, if you knew what the temperatures of those were. And I think we have to default to Ed May for what it is, but I can say, Rick, that the two, so the average, I guess the answer would technically be is one's kind of like the cold, one's kind of the hot. And as long as you're getting straight lines or a little bit of a curve of your therm models, you're doing okay. It's when those lines bend a lot and they connect, then you get condensation. But maybe, Laura, maybe you know more about those green and blue lines of your therm models of that lovely slide that I've already copied twice, and if you have an opportunity, she might post one last time.
I will happily post it, but I absolutely cannot answer that any better than you did.
Great,
So.
great, Rick. So we're gonna default to Ed May for the answer, and one day, but you can see those the green and the red lines. The fact that they're straight is great. In the kind of left center one where there's bending, I can say at least you're not getting collisions, but that's why they've insulated that, because if they didn't put in that orange insulation, you could get condensation happening there, and that was a bit of a concern. And I mean, most people never even understand this detail, and the fact that you know, they recognize that as a potential issue for, you know, condensation. I mean, the other default that maybe in the future you guys consider again is that kind of rule of thumb is you put the middle of the glass, you align it to the middle of the R value of the insulation of the wall. And I'll leave you guys with trying to figure out what I just said in the math of that, but that's a default.
We were actually able to do that on, so the detail we're looking at here, the top row, second from the left, that's a sliding door. There's only one of those on the project and the rest are swinging. So for the swinging doors, we were able to get the sill, like get the whole door frame really solidly inside the insulation layer. It's not exactly on center, but it's pretty good. This sliding door, because it has such a massive threshold, could not quite do that. So this is that jog in the therm layers, and you know, it's sitting on the concrete a little bit. That's definitely the worst example of that, but yeah, something to strive for. The nice thing is we get 25 tries to do this same house like really well. So
well, again, like you said, this is a mock-up. It's done really well, and the fact you can fine-tune it is great. And the fact that you have a great team, again, I mean, this is the whole thing. We're not all excellent or proficient in all this. This is why we need a team to just chime in and have discussions and make things better. One thing that James asks is, where exactly in the Catskills are you? Because he really wants to come see it. He's close enough where he's nearby. So yeah.
We're just outside of Livingston Manor, about 10 minutes or 5 minutes away from Livingston Manor.
Okay.
If you Google 302 Huber Road.
There we go. All right. Well,
Road, you'll get a point. You'll find us.
Well, hopefully we'll again have an opportunity to get to New York for some event, and we can do a road trip, because I know James has a Passivos pub for all us to get to. We've got this project to see, and we've got other ones. So,
yeah, James, if James wants to, definitely let us know in advance. We'd be happy to meet you out there.
All right, everyone. This has been an amazing 2 hours. I hate to stop it, but we're really lucky to have the presenters stay as long as they did and carry with questions. I think we got them all answered. And again, just bravo to the work you guys are doing. This is an inspirational project, and I can't thank you enough for just coming up here and again putting it in our database of projects so we can share with the rest of the world. So just honestly, bravo. Oh, Steve Gleckman, do you have a question, or did you have a comment, or you're posting something in the chat? What are you doing before
one easy final question? What was your design software, and what was your fabrication people's software, and how did you mesh?
Benson Wood is CADWorks, and for the design from the architecture, did you guys do Revit?
We use Vectorworks.
Oh,
and do they use Vectorworks, or do they use CADWorks?
They use CADWorks.
Oh, okay.
Seems like a lot of fabricators are using CADWorks. I use Vectorworks too, so I'm looking forward to.
And again, because I'm big into prefab, the reason for CADWorks originally is it is easier to get your design shipped off to Weinman lines or the Hundiger lines. So that's kind of why a lot of people default with it. Again, go back to our one of the 3 prefab summits. I might have answered that question more in detail of why that software matters, but A lot of times, I mean, if you said, hey, what software would you buy if you're starting up a new prefab company, it would be CADWorks. So
Right.
yeah, and again, I'm not supplied or sponsored by CADWorks, but I've done 20 years of research in it, and I find it's enough to get you started, and then you might differ between Dietrich's and a couple other ones. But if you end up going with Hundiggers and Wyman lines, CADWorks is a great little
Cool.
starter to go with because of a whole bunch of things. So
Thanks.
All right, everybody. Thank you for sticking around for the time you did. Appreciate you all coming. Again, Laura, Buck, and Greg, like I said many times tonight, just bravo. And for everyone else, we will see you tomorrow. And if you're still wanting to hang out, our good friend Mark Willie is on the Shop Class podcasts, and I'm going to put that link in the chat if you want to hang out with other cool people. And I'm going to put back in the chat for tomorrow's link that Zach did earlier. And hopefully we will see you all in the morning. And for our friends across the pond, that might be later on Thursday, but at some point. Oh, come on, Barbara, we'll see you. You're a diehard. If I was going to bet on anybody, we'll see you. Again, I don't know exactly what that time is.
No,
but...
I think it's going to be like 2 a.m.
Oh, whatever. You'll have a
Yeah,
cup of
exactly.
coffee and you'll join it because
Yeah,
you know,
sure.
you'll wait for the reposting next week, which of course will follow. So again, subscribe to the Passive Accelerator YouTube page. You get all the links and the updates. And if not, again, you can always default to the Accelerator page where Zach and the rest of the team, Kim included, will have those things posted. So I think, Zach, I'll turn over to you for any final words if I missed anything, but another amazing night in the world of Passive Accelerator.
Oh, it's fantastic. Thank you, Sean. And thank you, Buck and Laura and Greg. Really inspiring. So everybody have a great night.